Assalamualaikum. Welcome to all. You can see this question here. I'm going to solve this. In combustion chamber, oxygen diffuses through air. So oxygen is diffusing at this carbon surface here. When it reacts to give CO or CO2. So this we have three cases here. So reaction at the surface may be assumed instantaneous. So all diffusion limited. Rate of reaction is 0. So determine the rate of oxygen diffusion per hour. Okay, so you can see this Z equals 0 is surface, oxygen is diffusing in, CO is CO or CO2, whatever it is diffusing out. So if you consider the first case here, only CO is produced. Okay, so you can see the reaction will be C plus O2 giving you CO2 gas. Carbon is solid, oxygen is gas, right? So this is like A, this is A, this is B. So you can say direction of diffusion of A and B is opposite. So one is diffusing in and otherwise is being produced and diffusing out from the surface. So if you apply the stoichiometry here, we want to relate the flux. Okay, so Na, A is CO2, CO2 is product. So Na divided by 1, because we have 1 mole, equals Nb. Okay, sorry, this is CO only, right? So this is CO, not CO2. So only CO gas. So C plus O2 is 2CO. This we can make it 2. So we have to balance the reaction, right? Stoichiometry. So now we are trying to relate flux of A, which is oxygen, with the flux of B, which is CO. So Na equals Nb is the product, so opposite direction. So and stoichiometry 2, stoichiometric coefficient is 2, so minus 2. So if we are trying to relate Nb in term of A, will be minus 2Na. Okay, and then this is Cartesian coordinate. Okay, so if you apply the differential equation term, so you have no reaction, and only z direction. So from there you will get this term only. dna dz is 0, so that is naz is constant. Naz is not changing with z. Okay, so now let's go to the flux equation. Naz equals minus c dab dya over dz. This is the molecular diffusion term, plus ya, the bulk motion, Naz plus Nbz. Okay, so now when this term we need to reduce Naz plus Nbz. So Nbz is minus 2 Naz. Nb is minus 2 Na. Okay, so this term Naz is minus dab dya over dz plus ya. Nbz is minus 2 Naz. So Naz minus 2 Naz. So Nbz is minus 2 Naz. Okay, so from there we move and then NaZ equals minus C dAB dYA over dZ. This is NaZ minus 2 NaZ, so this is YA minus, okay, minus YA NaZ. Now just rearranging the equation in terms of NaZ. So NaZ 1 plus YA equals minus C dAB dYA over dZ. Okay. Now just separate the variables. We need to integrate. This is a differential equation now on our YA and dA. So dYA over 1 plus YA equals dYA over 1 equals NaZ and this is dZ divided by C dAB. So we integrate from where to where? We integrate from 0 to delta, right? So Z limit of integration is 0 to delta, and this is from YA1 at the surface, or fraction of YA1 to YA2. Now let's see what is YA1 and YA2. So at the surface, reaction is going on. So oxygen is diffusing and giving CO or CO2. So at this surface, there is no concentration of oxygen. So YA1 is 0 here. Okay. And in the bulk, the concentration, the mole fraction is given. So YA2 is 0.21. Okay. So YA1 0, YA2 0.21. So just integrate this. Ln 1 plus YA limit is from 0 to 0.21 equal NaZ is constant divided by C dAB delta. Okay, so we have to find the NaZ. So NaZ is basically C dAB ln 0 ln 1.21 minus ln 1, right? Ya is 0, ln 1 will be 0 and divided by delta. So this is question for flux. This is delta. Okay, this is first case. Okay, and I was missing negative here, right? So NaZ is negative. Why? Oxygen, let's see the direction of diffusion of oxygen. It is diffusing in this way, this direction, and our Z is from here. Z is in this direction. So that's why it's negative. If we calculate Na as flux for CO, it will be positive. Okay. Now okay, let's see this second case. Okay, I will not solve complete, but I will solve for like only carbon dioxide is formed. Okay, only carbon dioxide. So what will happen in this case? Part B, C plus O2 is CO2 gas. Okay, this is also gas. So this is balanced now. So NaZ equals minus NBZ. So this is reaction, but this becomes like equimolar counter diffusion. A is diffusing in, B is producing but is diffusing out. Okay, A and B. So this becomes case of equimolar counter diffusion. So NAZ plus NBZ equals 0. Okay, so I want you to reduce this equation and move this equation. NAZ plus NBZ is 0, so this whole term will be 0, this term will be 0, and then you have only this one. So integrate this to solve. Okay, now let's see part C. Part C, the reaction is given, so where CO and CO2 both is being produced. So 4C plus 3O2, 2CO, 2CO2. So in this case, the part C also I will do. Part C is 4C solid plus O2 gives you 2CO gas plus 2CO2. So again I will write the flux. So this is A, this is B, this is C. Okay. So now try to let the flux. Na divided by 1 equals minus Nb divided by 2 equals minus Nc divided by 2. Okay. So now what we have? We have Nb equals minus 2Na and Nc equals minus 2Na. Okay. So now if you want to write flux in terms of part C, I'm solving. Okay. Uh, where we have CO and CO2 both as product. Okay, so we start from here. NB, not this one. So NB is, okay, let me write again the reaction. So part C is 4C plus O2 giving you 2CO plus 2CO2. Okay, so basically we should have here 3O2. 2 plus 2 should be 3O2 here. Let's see the reaction here. 3O2 exactly. So now, yeah. So what do we have here? Na, this is A, this is B, and this is C. So Na divided by 3 equal Nb divided by minus 2 equal Nc divided by minus 3. Okay, or if you say reactant in opposite direction, so we can say this is negative and this is positive. So now what do we have here? Nb equals minus 2 over 3 Na, and Nc is also minus 2 over 3 Na. Okay, so now if we go to this equation, Naz minus C dAb dya over dz plus ya. Now we have Na, the flux, this bulk motion Na, Nb, and Nc. Okay, so what we have here, this term is as it is, and then we need to reduce this ya. Na, Nb is minus 2 over 3 Na, and Nc is minus 2 over 3 Na. Okay, so we need to reduce this term ya. This will be 3 2Na minus 2Na, sorry 3, so 3Na minus 2Na. So this term, okay, so just simplify this. Ya 3 minus 4, 3 minus 4 is 4, sorry, 3 minus 4 is minus 1, so minus Na over 3 and we have C dAb dya over dz, and here we have Naz. So take this side, simplify it, and integrate it. Bonding conditions are the same. Okay, so I leave this part for you. I hope this will help. Thank you.